All right, my friends, back at it once again. This one is a calculator problem. I know that because it says calc right there in the corner. So we're going to have, this is the rate of change. So it's important to understand that we are given a rate of change, right? Rate of change means slope, and slope in calculus means the derivative. Okay, so there is some mosquito function, right? The growth rate of mosquitoes on this island. And this is the rate at which those mosquitoes are growing. 5 roots of t times the cosine of t over 5 mosquitoes per day. So some mosquitoes die, some mosquitoes are born, some mosquitoes die, whatever. Show that the number of mosquitoes is increasing at time t equals 6. So that means if f prime is positive, then f is increasing. Right, we've had a lot of these types of questions. Whenever we're talking about increasing or decreasing, we're looking at the derivative of the function that we are talking about. Okay, so is our function about mosquitoes? What is our function talking about? The rate of change of the number of mosquitoes. So there is some number of mosquitoes function. This is the rate of change. And once again, rate of change means derivative. So I simply have to plug in 6 into my rate equation that I am given. 5 cosine of 6, 5 roots of 6 times the cosine of 6/5. Okay? I just have to plug 6 into my given equation because that is the derivative of the number of mosquitoes, right? I don't have a function for the number of mosquitoes. But this is the rate of change of the number of function of mosquitoes. Rate of change means slope. So I'm going to put that into my calculator. I'm going to see if it's positive or negative. I get positive 4.43796. Okay, so we have shown that because the rate is positive, right, our derivative is positive, the rate is positive, that must mean the number of mosquitoes is increasing. Okay, now at time t equals 6, this is part B, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? So this is going to be a derivative of my rate problem. Okay, derivative of rate. Because if the, right, so this is the derivative, this is our f prime of some mosquito function f, right? The number of mosquitoes is your f function. So the rate is your f prime and the derivative of rate is your f double prime. So if we relate this to particle motion, right, the first derivative is velocity and the second derivative is acceleration. If the first and second derivative have the same sign, then it is increasing, right? The rate of change is increasing. Basically, we're speeding up. Okay? And if they're opposites, then the rate of change is decreasing, right? Increasing at a decreasing rate. That means our graph is going to be concave down at that instant. So we're going to use our calculator and use the derivative at a point function. We're going to plug in your R equation and see what the value of r prime of 6 is. So we have a negative value there. So what can we say about the rate of increasing? We can say that the number of mosquitoes is increasing at a decreasing rate because the first derivative is positive, but the second derivative is negative at t equals 6. Okay, so we could have put r of t here and r of t there, and then put t equals 6. So yes, t equals 6 is probably superfluous information. Since I have a 6 in both of those places, I probably didn't need to put a 6 there anyway. But just to be safe, make sure we're talking about at that time at t equals 6, because that's what it says in your question. So here's 24. This is just finding a derivative using which of our derivative rules? This is the quotient rule because we have a fraction. So quotient rule, low times the derivative of the high function minus the high function times the derivative of the low function over the low function squared. Low d high minus high d low over low low. So the low function is 4 plus x squared times the derivative of 3, which is 0, minus 3 times the derivative of 4 plus x squared, which is 2x, all divided by 4 plus x squared, quantity squared. Okay, so anything times 0 is 0, so we have a minus 6x on the numerator, and I have 4 plus x squared, quantity squared in the denominator. Is that an option? Oh yes, there it is. The first option is A. That is going to be our correct answer. Okay, 25, what are we asked for here? We're asked for a relative maximum. And anytime we're asked for relative maximum, we're looking at the extreme value theorem. Okay, so extreme value theorem wants us to do a couple of things. Number one, find the critical points. Okay, find your critical points. And then after that, we would find the y value at each of those critical points. And at your endpoints if we had an interval. Okay, so if we really wanted to justify this, if this were an FRQ question and we wanted to justify the maximum, we would find the critical points. And we do that by setting your derivative equal to 0. Okay, that's where our graph has a horizontal tangent line, okay, at the max and at the mins. And then you find the y value at your critical points and your endpoints by plugging in those into your equation. Okay, but we just want to know where we have a relative maximum. So we're looking for the top of our hill, so our graph needs to be going up, and then our graph needs to be going down. So in other words, we have a positive first derivative followed by a negative first derivative, and this is one of your zeros or your critical points. Okay, so let's go ahead and let's get that done. So let's find the derivative of x to the third minus 3x squared. Let's see, let's go up here. X to the third minus 3x squared. So f prime is 3x squared minus 6x. And I want to know when is that equal to 0. Okay? So this is not a true quadratic, but it's still factorable, right? There are common factors, common multipliers, and those are 3x and x minus 2. 3x and x minus 2. So I have zeros at 0, and I have a 0 at 2, right? So those are my critical points. I'm going to put them on a number line and do a little sign analysis. 0 and 2, those are my critical values. Okay? So what is the sign of any number less than 0? So let's pick a number. Pick any number less than 0. Negative 1. So what is the derivative at negative 1? Well, that's 3 times 1 plus 6, which is positive. So to the left of 0, I have a positive derivatives, which means my function is increasing, right? If your derivative is positive, your function is increasing on that interval. Okay, let's check 1, right? 1 is between 0 and 2. So what's the derivative at 1? That's positive 3 minus 6. Well, that's a negative number. So in between here, we have a negative, which means our f is decreasing on that interval, which makes me think about where's there going to be a max. Right? There's probably going to be a max right there. And we can probably stop, because I'm pretty sure that after this, I'm going to have another positive value. So we're going to have a minimum at 2, and a maximum at 0. Is that an option? Yes, maximum at 0. Right, relative maximum, so not an absolute max, but it happens at your critical points. And to find a critical point, you set your derivative equal to 0, and then we do a sign analysis by plugging in a value on each interval and deciding whether they're positive or negative. So our last one is taking the derivative of this function and evaluating it at -1. So first, let's change everything into a power, no more fractions. Let's do that first. So if we were to change 1 over x cubed into a non-fraction, that would be x to the -3rd power. Minus, if we were to change 1 over x into a non-fraction, that would be x to the -1st power. And then our next one, x squared, well, that's already not a fraction, so we're just going to leave it as x squared. Okay? I am much better at taking derivatives as non-fractions than I am as fractions. Okay, so what's the derivative of x to the -3? Well, that's -3x to the -4. Okay, and then minus -1, which is a +1 x to the -2, because we subtract 1 from our power every time. And then plus 2x, that's the derivative of x squared. And now I want to evaluate this at +1, right? -1? Oh, even better. -1 plus 2 times -1. Okay. This is -3 over 1 to the +4. Right? What's 1 to the +4? Sorry, -1 to the +4. When I raise a negative to an even power, this is a positive. So my first number is -3 plus, okay, this is, let's see, 1 over -1 squared. Okay, once again, negative raised to an even power is, right, 1. So 1 over 1 is +1. So I'm adding 1 there to -3. And then, of course, 2 times -1 is -2. So -3 plus 1 minus 2 is -4. Is that an option? There it is, option B is our final answer of our review. Okay, so it's important to know, what is the function that we're given? Is it a position function? Is it a velocity function? Is it a acceleration function? And then if we're asked about increasing or decreasing, right, if the derivative is positive, your function is increasing. And if the derivative is negative, your function is decreasing. Okay? Have a wonderful time. Do your best. And we'll see you on the next video. Okay, bye.